So my talk is going to be about live coding a REST program or like a REST application and deploying it on Cloudflare workers. A little bit about myself. As Cesar mentioned, I'm Sven Solo. I'm working at Cloudflare as a system engineer. I worked for 5.5 for almost 6 years now in the company. I worked on many different projects. So I guess the first question is, why would you deploy REST on workers? At this point, it's more a personal preference. If you prefer REST, then it's an obvious answer. But also, if you like having some kind of type safety in your programs, REST is a very good fit for this because you can use a TypeScript, but you're never really sure that what the types you declare in TypeScript are actually the types that are present at runtime. REST kind of enforces this, and you have for more CPU intensive applications or memory intensive applications, usually REST is a better fit for that kind of stuff because you can squeeze an extra bit of performance out of it. Also, this is more like a personal preference again. I really like the error handling that you have in REST. You'll see in my demo, I'll be using a bunch of this. If you port existing libraries in REST is obviously easier to use it to deploy it. If you port existing C code bases, like we did for D1, for example, it's a SQLite that we packaged inside REST and deployed on workers. So the demo app I will be showing today looks like a bit like this. You have a big input that you can text in. When you click on prompt, it's going to send that input to an AI. I will be using some Llama model. I'll try to find something nice. The prompts, when you send them, they're registered inside the database. And you have a button to see the history of all the prompts you have been sending to this thing. So what we need is a database. Oh, it's a bit small, but what we need is a database and a way to run a model. And Cloudflare has D1, which is a SQL database. It also has Workers AI, which allows you to run inferences. Maybe quick question. Did any of you use D1 or Workers AI yet? A few. If you look at a high-level perspective of how that app will be designed, this is your client customer talking to a React application that I already pre-built because it's not the point of this talk. And just the React application talks with the worker over an HTTP API. The worker then talks to Workers AI. It's at the top, it's a bit cut, but that's Workers AI. And at the bottom, you just have a database. So the worker talks to those two services and interacts with the React UI using HTTP. And to do this, you can also easily do it yourself because we have a template that you can use to start building your own Rust application. And this template has it sets up two tools for you. One is called Wrangler. It allows you to interact with pretty much all the Cloudflare services and deploy workers and configure them, test them, all that cool stuff. And then Workers AI, it's a library Workers RS. It's a library that allows you to interface with workers from Rust and allows you to deploy Rust on workers. Oops. So imagine I run this command. I'm not going to do it now because it was a bit long. But I have my project here. Oh, now I need to do this in the code. Okay. It's so big on my screen. So this is what the template looks like. it already has a UI inside of it, a React application. I changed it a bit. If you clone it on your laptop, it's going to look differently, but the point is that there is a UI. And I have a few files. I have an initial .sql file. I'll be using this to create my table inside the one. So I just one column, just a prompt, very simple. Not really recommended, but it's okay. And then, as I mentioned, you have wrangler.toml, which contains the configuration of your worker with my Swift account ID. And then you have the main entry point of the worker. It doesn't do much. It just has a /hello pass that is going to call the get hello at the top. So basically just return hello on /hello, which we can test by running wrangler dev, which is going to start your worker locally. So compile. So I compile my Rust code, and that's what you get when you go on the website. So as I said, it's just a text input and 2 buttons. When I click on them, nothing happens. This is the loading animation. It just fired 2 requests on my backend, but they are both 404 because we don't have anything implemented yet. So as you can see, when you type something and try to prompt the AI, is sending a request on /API/prompts. It's a post request with the content of the prompt. So now we have to implement all of this. And I'm going to do this by, I'll start by doing the inference part. So I need an endpoint that is post API/prompts. It's going to call a new function that I will call post prompts. I'll just rename it up there. So this on the top, maybe I forgot to mention it. This is my request handler. So everything that is going to be calling /API/prompt is going to be calling this function. And in this function, I get access to the request that the client sent me, and also some kind of state that is shared inside my application. And in the state, I'll need to add the connection to the database, the connection to workers there. So the first thing I want to do is set up my workers AI binding. I never remember, so I'm just going to check online. If you go on the Cloudflare documentation, you have workers AI. If you click on Get Started, there we go. So this is something that you need to configure in your wrangler.toml to connect your worker to workers AI. And it's going to be available inside the worker on this name or binding, as we call it. And then I can, using workers -rs APIs, I can have access to this binding. So I get my workers environment and env, and I can get my AI binding using this. And I will just put it inside the state because I need to have access inside the request handler. Just AI. Yeah. Okay. And now I'm going to send a prompt to the AI using just the run method. The run method takes the name of the model and the input. To determine which model I'm going to use, I'm also going to look up the Cloudflare documentation. So once we are on the workers AI documentation and in the model tab, I think, yes, you have a bunch of models. What I need is one of the text generation one. Let's go for llama. This one looks good. So just copy the name and put it inside the run function. And then you need to specify an input. And actually, I need to type the input. So LLM input. Yeah, we can ignore the errors for now. Because the other thing I wanted to mention is that if you go a bit down on the same page, you have all the types for the model. So the inputs and the outputs. And here I can see that inside the input, I just have a prompt. So I'm going to type this as a prompt being just a string. And so my input is going to be LLM, just a prompt. And for now, I'm going to just say test, just to get started. And so if I compile this, never mind. If I compile this at the bottom, I don't know if you can see it, but it says that LLM input cannot be serialized. And to teach Rust to serialize something, we need to install a package called CRD. CRD is just a library for annotating structs and allowing them to be serialized or deserialized to YAML, JSON, any kind of representation. So I already installed it locally, but I can do it again for a demo. Just cargo add whatever dependency. It's very similar to NPM. So I have it, and now I need to derive from CRD serialize. So now I have my input. I pass it inside the run function. We also need to specify an output. So if I go back inside my documentation, the outputs is just a response field. So I'm going to type my LLM output to be a response string. And there's going to be my response. And the input and the output is going to be serialized and sent to workers AI. I need to also deserialize the output of that. So I just annotate my struct with deserialize. And now it should compile. Yes, it does. I'm going to send just the response as a HTTP response so we can see. Oh, it's a future. I need to await it. All right. If I run my worker again, the prompt doesn't matter because I hard coded it to test. But now it's making a request to workers AI on my laptop with a prompt that I specify in the code, and is going to reply with the actual response. So not anything useful right now. So now the next step for me, I want when the user types in his prompt here and clicks on prompt, I want to be able to send this to workers AI. And to do this, I need to declare what input the user is supposed to send me. So if you look at the request of a prompt, I have just a prompt field as JSON. So to get the data from the client, so this is very similar to a JavaScript API that you have in Workers. You can get the request body as a JSON. The JSON is going to be a LLM input because I just have a prompt field inside of it. I also need to be able to deserialize it, so I'm going to do this. Annotate the structure with deserialize. I also complain that the request needs to be mutable, so I'm just adding the mutable keyword there. And now inside my data, I have LLM input and I have a prompt, so I can just pass it to my run function. And now if I restart my server, I should be able to prompt the AI with what I specify here. So if I say, for example, are you a car? And I send this to Workers AI. Yeah. So we send this and it replied, thanks for asking, I'm not a car. So we took the prompt from the user, we sent it to Workers AI, we got the response back, we sent it to the client. So far easy, but we don't have any history now. That's the second thing I wanted to do in my app, is collect the inputs from the user as prompts and store them inside the database. So for this, you can also use Wrangler. So if you type Wrangler D1, you get a list of all the comments that are available inside D1. And you do create, and I'm going to call it further. So I have my database called Paddle. It gives me some configuration that I need to add inside my Wrangler.toml. So same idea, we bind the database to the worker. It's available using the database name. So now if I go back to my worker, I need to add it inside my state. So database, it's called DB, and here, D1. I need to put it inside my state. The D1 database. Oh, and I forgot the database that I just created is empty. I need to add my table inside. And remember, I had my initial .sql that contains the table that I need to create. So now it's Wrangler D1 execute the name of the database, and I can pass in the file I want to use to run. I can run just SQL. And I specify local because I'm only doing locally right now. So now I have, presumably I have my prompt table inside my database. So now I should be able to add some prompts inside. So I have my binding inside the state. Actually, let me look up the documentation. So there's the documentation for workers RS, is the library I mentioned earlier. And if I check the D1 database type, it has a prepare method that I can use to prepare SQL statements. I'm going to use this to insert into prompts. It only has one column, so it's very easy. Let's make it a bit prettier. Oh, yeah. Prepare returns this. So once I have prepared my statement, I need to bind a bunch of values. So the value is going to be data dot prompt. And there's a small subtlety. We need to pass JS values, which is a different type. And prompt is a string. But if you say dot into, you're just going to convert that string into a JS value. So now I get a Rust specific error. I just have to clone my data because it has been moved in between codes. I'm just going to do it quickly. Okay, so now we have, no, I'm not done yet. So I have bind my values. I also need to run my query to actually run it. I also need to await it because it returns a promise. Oh, yeah. So now in theory, we send a prompt to the Llama model, and we also save that prompt. Let's try it. Uh, Nothing crashed, so let's say it's good. Now the second thing is that since I inserted some values, I also should be able to see them. If I look at my front end on my UI, when I click on see history, it does /API/prompts, and it's a GET request. So I'm going to implement this. I'm creating a new endpoint, a new request handler. The request doesn't need to be mutable. And I need to select the data inside my database. So I can say select everything from prompts. I don't need to pass any values because it's not a prepared statement. And I think I need to use all because run executes the command, the SQL query, but doesn't return anything. I need to use all. And yeah. And it returns a D1 result. D1 result has a result inside. And I need to deserialize it again. I can just reuse the LLM input type because it's only a prompt colon inside my database, my table. I also need to await this. No, I don't need to await it. Okay, my bad. So now we should have our prompts, and I need to return it to the client. I can return JSON to the client using this. So now in theory, if I restart my server, I should be able to see the content of my prompts table. And we do. So now when I prompt my model, the prompt is saved inside the database. And now when I click on see history, it's loading just all the prompts that I have in my database. Actually, I noticed there's an error. This is because when I prompt the AI, the front end is expecting JSON to be returned, but I don't think that's the case. Yeah, we just return a string. So I also need to return JSON here. I need to add the serialization as well here. Okay. So now we should see the response from the AI inside my app. Okay, yeah. And we also see the prompts from my database. So that's it for my demo. I forgot to publish it on GitHub, but I might do it. There are a few things missing. There's no streaming, which makes the experience a bit slow for the user. And also we could add different models. We can do many things. But I think that's mostly left up to you. There's a template you can use to get started with deploying Rest on Workers. Just try it out.